bread, rice, potatoes. If you have ever been told you have high blood sugar, prediabetes, or type 2 diabetes, there is a good chance someone has told you to cut these foods out entirely. And if you have tried that, you already know how realistic that advice is for most people. These are not fringe foods. They are staples in virtually every cuisine on Earth. They sit at the center of family meals, cultural traditions, and daily habits built over decades. Telling someone to simply eliminate them is advice that sounds clean on paper and falls apart completely in real life. But here is what that advice gets wrong. The problem was never the food itself. The problem is how those foods are prepared, what you eat them with, when you eat them, and what happens to their molecular structure before they reach your plate. Because all of those factors, every single one of them, dramatically changes how your blood sugar responds. And the science behind this is not theoretical. It is supported by multiple randomized controlled trials showing that the same gram of carbohydrate from the same food can produce a completely different blood glucose response depending on how it was handled before you ate it. In this video, we are going to go through every practical, science-backed strategy for eating bread, rice, and potatoes without the blood sugar spikes that drive insulin resistance, worsen diabetes, and accelerate aging. You do not have to give up the foods you love. You have to understand them better. Part 1. Why blood sugar spikes matter so much. Before we get into the strategies, it is worth spending a few minutes on why blood sugar spikes matter so much, particularly after the age of 50. Because a lot of people have a vague sense that high blood sugar is bad without fully understanding the cascade of damage that repeated spikes actually cause. When you eat a carbohydrate-rich meal, the carbohydrates are broken down into glucose and absorbed into the bloodstream. Blood glucose rises. Your pancreas detects the rise and releases insulin, which acts like a key that opens cell doors to let glucose in for energy use or storage. Blood glucose comes back down. Under normal circumstances, this is a well-regulated process that works smoothly. The problem begins when this process is triggered repeatedly, multiple times per day, every day, for years. Cells that are constantly exposed to high glucose and high insulin begin to resist insulin's signal. They become less responsive. The pancreas compensates by producing more insulin to achieve the same effect. Blood sugar stays elevated for longer after each meal. The cycle of insulin resistance deepens. And eventually, the pancreas, which has been working overtime for years, begins to lose its capacity to keep up. Blood sugar regulation breaks down. Prediabetes develops. And if the trajectory continues, type 2 diabetes follows. But the damage from repeated blood sugar spikes goes beyond the development of diabetes. Every time blood glucose spikes sharply, it triggers a process called glycation, where glucose molecules attach to proteins and fats throughout the body and form damaging compounds called advanced glycation end products. These compounds accelerate aging at the cellular level. They stiffen blood vessel walls. They promote inflammation. They damage the kidneys, the eyes, the nerves, and the heart. The chronic low-grade damage from years of blood sugar spikes is one of the most important and underappreciated drivers of the health problems that accumulate after 50. The goal of everything in this video is to flatten that blood sugar curve after meals, not to eliminate carbohydrates, not to follow a restrictive and unsustainable diet, just to give you the tools to eat the foods you enjoy in a way that produces a gentler, steadier glucose response and puts your metabolism under far less strain. Part 2. Resistant starch, the most powerful tool most people have never heard of. The single most powerful and least known strategy for eating starchy foods without spiking blood sugar is the use of resistant starch. And the most remarkable thing about it is that you can create resistant starch from foods you already eat simply by changing how you prepare them. Here is the science. Most starches found in bread, rice, pasta, and potatoes consist of glucose molecules linked together in chains. When you cook these foods, the starch molecules absorb water, swell, and become what is called gelatinized starch. Your digestive enzymes, starting in the mouth and continuing in the small intestine, are extremely efficient at breaking down gelatinized starch into individual glucose molecules. The glucose gets absorbed rapidly into the bloodstream. Blood sugar spikes. Insulin surges. But when you cook starchy food and then allow it to cool before eating, something chemically significant happens. A process called starch retrogradation occurs. The gelatinized starch molecules, as they cool, begin to realign and form tightly packed crystalline structures. These crystalline structures are physically resistant to your digestive enzymes. They cannot be broken down in the small intestine. This transformed starch is called resistant starch. Instead of being rapidly absorbed as glucose in the small intestine, resistant starch travels intact to the large intestine, where your gut bacteria ferment it. And that fermentation produces short-chain fatty acids, particularly butyrate, which is one of the most beneficial compounds produced anywhere in the digestive process. Butyrate improves insulin sensitivity in muscle and liver tissue. It reduces intestinal inflammation. It strengthens the lining of the colon and protects against colorectal cancer. It feeds the beneficial bacteria that form the foundation of a healthy gut microbiome. Multiple studies confirm that cooling cooked rice or potatoes to refrigerator temperature, around 39 degrees Fahrenheit, for 24 hours significantly increases their resistant starch content compared to freshly cooked starch. And clinical studies show that eating cooled and then reheated rice or potatoes produces measurably lower postprandial glucose, meaning lower blood sugar after eating, and lower insulin spikes compared to eating the same foods freshly cooked and hot. Here is the practical application. Cook your rice, potatoes, or pasta. Let them cool completely. Refrigerate them for at least several hours, ideally overnight. Then reheat them before eating. The reheating does not reverse the retrogradation. The resistant starch you created during cooling remains resistant starch even after reheating. The texture will be slightly different from freshly cooked, particularly for rice, but it will be close. And the metabolic benefit is significant. This is not a minor effect. It is a structural change in the food itself that fundamentally alters how your digestive system processes it. And it requires no additional ingredients, no supplements, and no radical change to your eating habits. Just a different sequence in how you prepare the food. Beyond cooking and cooling your existing staples, there are also foods that are naturally high in resistant starch regardless of preparation. Legumes are the most important category here. Lentils, chickpeas, black beans, kidney beans, and most other beans and peas are naturally very high in resistant starch. This is partly why legumes consistently show up in the diets of the healthiest and longest-lived populations in the world. Green unripe bananas are another excellent source of resistant starch. As bananas ripen and turn yellow, their resistant starch converts into regular starch and sugar, so the greener the banana, the higher the resistant starch content. Whole oats, particularly steel-cut or rolled oats rather than instant oats, also contain meaningful amounts of resistant starch. Part 3. Food pairing and the power of what you eat alongside your carbs. The second major strategy is food pairing. And the research here is striking because it demonstrates that what you eat alongside your carbohydrates can reduce the blood glucose response by as much as 50% without changing the carbohydrates themselves at all. A meta-analysis of 154 randomized controlled trials found that simply adding protein to a carbohydrate meal reduced the glucose area under the curve, which is the total blood sugar exposure over time, by up to 50% in healthy adults. That is a dramatic reduction from a pairing strategy. The mechanism involves protein-slowing gastric emptying, meaning the stomach releases its contents into the small intestine more slowly when protein is present. Slower delivery to the small intestine means slower glucose absorption, which means a lower and more gradual blood sugar rise. Fat has a similar but somewhat different effect. Fat delays gastric emptying and also helps with insulin clearance, improving the sensitivity and efficiency of insulin signaling in ways that reduce the overall insulin burden of a meal. This is why rice and beans is metabolically better than just rice alone. Why potatoes with butter or potatoes with olive oil produce a gentler glucose spike than plain boiled potatoes. The fat changes the rate of digestion in a way that benefits your blood sugar response. The practical implication of this is to never eat starchy carbohydrates in isolation. Some people call this avoiding naked carbs. If you are going to have toast, have it with eggs and avocado. If you are having rice, pair it with protein and vegetables. If you are having potatoes, add olive oil or butter and something with protein. The carbohydrate content is the same. The blood sugar response is significantly different. Adding acid to your meals is another pairing strategy with solid evidence behind it. Vinegar, lemon juice, lime juice, and fermented foods like sauerkraut or kimchi all reduce the rate at which starch is broken down and absorbed. Vinegar specifically has been shown to improve insulin sensitivity in muscle tissue and to blunt glucose spikes through its effect on liver glucose production, a process called gluconeogenesis. Studies show that consuming vinegar with a carbohydrate-containing meal can reduce postprandial glucose by 20 to 30%. Adding a tablespoon of apple cider vinegar or red wine vinegar to a meal, using a vinegar-based dressing on your salad, or including a fermented food as a side are all practical ways to harness this effect. Part 4. Food order, the simplest change with one of the biggest effects. This is one of the most underutilized strategies in blood sugar management, and the research behind it is compelling because it demonstrates that you can produce dramatically different blood glucose responses from the exact same meal simply by changing the order in which you eat the components. A randomized controlled crossover trial that studied people with type 2 diabetes found that eating vegetables and protein before carbohydrates produced a 40% lower glucose area under the curve and a 31% lower insulin area under the curve compared to eating carbohydrates first. The same food, the same total calories, the same macronutrient composition, eaten in a different order. And the blood sugar response was 40% lower. A study from Japan using continuous glucose monitors in healthy adults confirmed the same finding. Eating rice last after protein and vegetables significantly reduced the postprandial glucose response compared to eating rice first. The mechanism is straightforward. When you eat vegetables and protein first, they create a physical and chemical environment in the stomach and small intestine that slows the subsequent absorption of carbohydrates. The fiber from vegetables slows gastric emptying. The protein triggers early insulin release in a way that primes the body to handle glucose more efficiently. And the presence of food in the stomach before the carbohydrates arrive means the overall absorption rate is slower and more gradual. The practical application requires almost no change to what you eat. It just changes when within the meal you eat each component. Start with vegetables and salad. Eat your protein next. Save the bread, the rice, or the potato for last. If you are eating at a restaurant and they bring bread or chips to the table before the meal, push them aside and eat your salad and protein first. This is a completely effortless intervention once it becomes habitual, and the metabolic benefit is substantial. Part 5. Movement after meals. The third major category of strategies involves what you do immediately after eating, and one of the most accessible and well-evidenced tools available is simply walking. A randomized controlled trial showed that a 10-minute walk taken immediately after a meal produced a measurable reduction in postprandial blood glucose. Not after an hour, not after 2 hours. A 10-minute walk taken within 15 minutes of finishing a meal. And the effect is not limited to walking specifically. Any form of light physical activity immediately after eating, climbing stairs, tidying the kitchen, light stretching, produces a similar benefit. The reason walking after eating is so effective comes down to a specific muscle group called the soleus, which is the large muscle in the calf, that runs from just below the knee down to the heel. The soleus is composed predominantly of slow-twitch muscle fibers, which means it can sustain activity for prolonged periods without fatiguing. And it is a metabolically significant muscle because it has an unusually high capacity for absorbing glucose from the bloodstream. Here is the critical biological detail. A muscle at rest requires insulin to absorb glucose. Insulin is the key that opens the cell door, but a working muscle, one that is actively contracting, can absorb glucose directly without needing insulin. The physical activity itself opens the cell door. So when you walk after a meal, your soleus and the other muscles in your legs are sponging up glucose from the bloodstream without requiring an insulin surge to do it. Blood sugar comes down faster. The total insulin exposure of that meal is reduced, and the metabolic stress on your pancreas is lowered. The timing matters significantly here. The peak blood glucose response to a meal typically occurs between 30 and 60 minutes after eating. If you walk before that peak, you are actively pulling glucose out of the bloodstream during the period when it would otherwise be accumulating to its highest point. Walking 2 hours after a meal catches the glucose on the way down and produces a smaller effect. Immediately after eating or within the first 15 to 20 minutes is when the intervention has the greatest impact. Even if you are eating out, even if you are traveling, 10 minutes of walking after a meal is achievable in almost any situation. It is one of the most accessible and most consistently supported tools for blood sugar management. Part 6. Carbohydrate quality, not just quantity. There is one more dimension of this topic that ties all the strategies together, and it is the distinction between carbohydrate quality and carbohydrate quantity. A lot of the conversation around blood sugar and carbohydrates focuses on how much carbohydrate you eat, and quantity does matter. But the evidence increasingly shows that the quality and processing of the carbohydrate, meaning how it was milled, what else it is packaged with, and how quickly it is absorbed, often matters more than the raw gram count. Think of it this way. Whole grain wheat berries and ultra-fine white flour both start from the same wheat plant. But when wheat is milled into fine white flour, the process grinds the starch into particles so small that your digestive enzymes can break them down almost instantaneously. The glucose floods into your bloodstream within minutes. It is like throwing sawdust on a fire. It burns fast and hot, and it is gone. Steel-cut oats or intact whole grains are structurally very different. The starch is embedded in an intact matrix of fiber, protein, and bran that your digestive system has to work through slowly. The glucose is released gradually over a much longer period. It is more like putting a log on a fire. It burns slowly and steadily, delivering energy evenly rather than in a single intense burst. This distinction matters enormously for the strategies we have discussed because it explains why not all bread, not all rice, and not all potatoes are metabolically equivalent. Sourdough bread made through a long fermentation process has a significantly lower glycemic response than commercially produced white sandwich bread, even when both are made from white flour, because the fermentation process partially breaks down the starch and produces organic acids that slow absorption. Parboiled rice has a lower glycemic index than standard white rice because the parboiling process partially gelatinizes and then retrograded the starch before the rice is even sold. Smaller, waxy potato varieties have a lower glycemic index than large starchy varieties like russets. The degree of ripeness of fruit follows the same principle. Unripe bananas are high in resistant starch. Fully ripe bananas are high in rapidly absorbed sugar. The same fruit, the same plant, dramatically different metabolic effects depending on ripeness. When choosing your carbohydrate sources, prioritize less processed over more processed. Intact grains over flour products. Whole fruit over juice. Legumes over refined starch. Parboiled or basmati rice over standard white rice. Smaller waxy potatoes over large russets. These choices, combined with the cooling technique for resistant starch, food pairing, eating order, and post-meal walking, create a layered strategy that allows you to eat the foods you enjoy while maintaining substantially better blood sugar control. Part 7. The timing of your last meal. The final strategy in this video is one of the most consistently overlooked, and the research behind it is clear. The time of day at which you eat carbohydrates significantly affects how your body responds to them. Specifically, insulin sensitivity follows a circadian rhythm, meaning it is substantially higher earlier in the day and lower in the evening. In the morning, your cells are most responsive to insulin. A given carbohydrate load produces a lower blood glucose spike and requires less insulin to manage in the morning than the same meal eaten at night. Multiple studies confirm this. The same meal eaten at dinner produces a higher postprandial glucose response and a greater insulin requirement than the same meal eaten at breakfast or lunch. In the evening, naturally rising levels of melatonin, the hormone that signals the body to prepare for sleep, actually inhibit insulin secretion. Less insulin means a reduced capacity to clear glucose from the bloodstream. So eating a carbohydrate-heavy meal late at night puts glucose into your bloodstream at the time when your body is least equipped to handle it. The practical recommendation from the evidence is to eat your largest carbohydrate-containing meals earlier in the day and to eat your last meal of the day at least 3 hours before bedtime. If you have a late dinner, making it lower in carbohydrates and higher in protein and fat will produce a much more manageable blood sugar response than eating rice or bread or pasta at 10 at night. The bottom line, You do not have to give up bread, rice, or potatoes to manage your blood sugar. You have to manage them intelligently. Cook and cool your starchy foods to create resistant starch before reheating and eating them. Always pair carbohydrates with protein, fat, or acid to slow their absorption. Eat your carbohydrates last within each meal. Walk for 10 minutes after eating. Choose less processed carbohydrate sources whenever possible. And eat your last carbohydrate-heavy meal earlier in the day. Each of these strategies individually produces a meaningful reduction in the blood sugar response to carbohydrates. Combined, they can transform the metabolic impact of your meals in a way that allows you to continue eating culturally meaningful, satisfying foods while protecting your insulin sensitivity and long-term metabolic health. The goal is not perfection, it is consistent application. Build these habits one at a time. Start with the cooling technique for rice and potatoes tonight. Add a 10-minute walk after dinner tomorrow. Change your meal order next week. Each layer compounds the benefit. Stay consistent, and we will see you in the next one.